So now we'll continue with the intermediate code generation. We'll start with the syntax tree. Now, so what is syntax tree? Syntax tree is an abstract form of parse tree. Parse tree shows you the derivative stepwise of how a grammar symbol is being derived to an set of terminals, what you have in the programming structure. Whereas parse tree gives you a very abstract form of, syntax tree gives you an abstract form of how it looks like. So now when you talk about a syntax tree, all the identifiers and the numbers act as the leaf nodes, whereas the intermediate nodes are the operators. So what has to be evaluated first? B minus C. So B minus C has to be evaluated. Now it is A star B minus C. It is not B minus C star A. So A has to be the left hand child of the star operator, and the right hand child will be minus, because B minus C is evaluated only in this intermediate node. And now here you have another B minus C with star and D. Now the B minus C becomes the left operand, and D becomes the right hand side operand of star. Now what happens? A star B minus C is evaluated in this part. B minus C star D is evaluated in this part. Now you have A plus A star B minus C. So I have created another node and then a plus to B minus C. Now this complete structure has to be added with the right hand side subtree. So from this plus you have an edge. From this star we have an edge to n plus. Now this is the normal syntax tree what we draw. You also have something called as directed acyclic graph. Now what is it? Here I have B minus C twice, which is printed in the syntax tree. Let me reduce it. We do a little bit of optimization. So in the directed acyclic graph, the common sub-expressions can be represented only once. You can have as many as edges you want. So instead of having 2 B minus C, I have only 1 B minus C which is generated. So you have A star B minus C. Now if you see in your syntax tree, you will have only one parent for every node. But here you have two parents. One parent moves on to this star, the other parent moves on to B minus C star D. Therefore, common subtrees are being eliminated, which means evaluation of common sub-expressions will be eliminated. Now you have A star B minus C. So this A was already created. Now this A has to be added with A star B minus C. So I have another edge which moves on. Such kind of expressions are termed as the representations are termed as the directed acyclic graph. Now going on, you have a syntax directed definition for DAG. As and when the syntax analysis checks whether the syntax of your program is correct, you can also do an syntax tree construction. Hope you remember the output of syntax analysis is syntax tree. So when the parser checks the syntax of the program is correct, we can also construct an parse tree. Now what happens here is any number, an identifier is a leaf node. So a leaf node has been created. You have two functions. One is the intermediate node and the other one is the leaf node. So I have created a leaf node which says that it is a num token type, number token which has some value. Then for the fifth one, it says it is an identifier token which has an entry in the symbol table. And here it's just an assignment. We are not going to do anything. But then when it comes to an operator, you create a node with three fields. One is the operator. The second one is the left hand side variable, and the third one is the right hand side value. Now these explanations we'll do it in the next video with some more examples saying how every node will be created. From the syntax directed definition, we can do type checking, we can do syntax tree construction, and also we can generate intermediate code. These three we'll see it in the next video. But then for one more representation, what you have is an postfix notation. So postfix notation we all know from our data structures. But then just to recap, we'll see B minus C has to be evaluated first. So minus comes ahead. So it is BC minus. And then this expression has to be evaluated. A, BC minus star. So A, BC minus star. And what about this one? It is BC minus. So I have done BC minus here. And then it is BC minus D star. So it is BC minus D star. Now if you go ahead, you have 2 plus. First this plus has been evaluated, and the second this plus has been evaluated. So what happens? It is A with A BC minus star plus. So that goes ahead. And then this part has to be added with this part. So what is this one? This part we have given it till here, till this plus. This is the next one, and then the last one is plus. So this is how you do an postfix notation. So here we end with the intermediate code representation, and then to continue we will go ahead with all the syntax directed definition, evaluations of intermediate code, construction of syntax tree and type checking in the next video. Thank you.